In the previous video, we saw that two objects, a heavy object and a light object, could accelerate at the same rate as long as we removed air from the equation. We can do the same thing in this case in a slightly different way by reducing the surface area on which the air can push. So in this case right here, if we drop the objects like this, the paper has a very large surface area on which to come into contact with air as it falls. So we can imagine all these arrows are air particles pushing up on the paper, and the combination of all of these creates a rather large force in comparison to the weight of the paper, thereby causing it to accelerate at a lesser rate than the book, which has a larger mass, resulting in a larger weight, which sort of overpowers the air a little better. Well, if we crumple up the paper to make the surface area smaller, we should see less of an effect of the air. So let's see what happens. Well, the result was pretty clear. The paper accelerated at nearly the same rate as the book. Maybe the book's accelerating a little bit more and hits maybe just an instant before the paper. But we can see that it's a much closer race than it was when the paper was unfolded. And if we look at this point here, we can see that the area of the crushed paper is so small, very little air can come in contact with it, compared to before when a lot more air could. So by reducing the surface area, the net effect of the air is reduced, and the objects accelerate at close to the same rate.